Alright, so here we want to solve this log equation. We have log base 6 of x plus log base 6 of x plus 5 equals 2. And now the issue with this equation is that there's two log expressions. Okay, so you're probably thinking, okay, I have a log expression, so I want to convert this to the exponential form, right? That is correct. However, we have to make sure that we combine these logs properly first, okay? So in this case, we're going to use the product rule, right? We see the plus in between here. So that means that we can combine these into one log. Okay, we'll combine these into one single log, but what are we going to do with the arguments here? Right, the arguments should be multiplied together. So x times x plus 5, right? That gives us x squared plus 5x, and that should equal 2. Right? So now, because we have this one log expression, okay, now we can convert this to exponential form. What is the corresponding exponential form here? Right, so we have 6 to the second power is equal to x squared plus 5x. And now we have a, well, in this case, right, a quadratic equation that we should be able to solve, right? 6 squared is 36. Okay. So let's subtract that 36 over, so we get 0 on one side. And notice what we get here, right? 0 is equal to x squared plus 5x minus 36. So this quadratic equation is going to be factorable, right? It's going to be, I sort of wrote the answer first, right? Is x plus 9 here times x minus 4. Okay, now we do get two values for x here, right? We get x equals negative 9 and x equals positive 4. Okay, so does that mean that both of these are our answers? And we got to be careful with these, right? And for log equations, right? Remember, what is the domain of a log function? Right? The domain is 0 to infinity, right? What does that mean? Okay, it means that the argument here cannot be negative. Notice what happens if you plug in the 4 here and the 4 in here, right? I mean, it's positive, so that's fine, right? This will work out. Yeah, but notice what happens when you plug in the negative 9 in here, right? We get log base 6 of negative 9, which does not exist, right? So what does that mean? It means that negative 9 is an extraneous solution, right? Okay. So we did the work, we did everything correctly. However, when we plugged it back into the original problem, right, it did not work because we ended up with a negative value. Okay. Now you got to be careful with this, right? There's only one answer here, right? The answer here is x equals 4.